differentiating y equals sin x and y equals cos x from first principles. Now, in order to do this process, you need to know the small angle approximations for A level, which are these. When the angle is small, I'm going to use theta in these formulas. When the angle is small, sine of theta is roughly equal to theta. Cos of theta is roughly equal to 1 minus a half theta squared. And to complete the set, tan theta is also roughly equal to theta. Now, the only ones we're going to need here are those two. But those three formulas there, you need to know for A-level maths. They're not in a formula sheet. If you're interested, they come from, they're shortened or truncated versions of the Taylor expansions of those three trig ratios. Right, let's crack on. Firstly, y equals sin x. There's the formula up here from the formula sheet. Let's apply it. So that first line there, I've literally just substituted, think of this as f of x is sin x. So there's our f of x there, so we've got to take away sin x. And f of x plus h is literally just sine of x plus h. Okay, to go any further, we're going to have to expand this, and that has to be expanded using the compound angle formula, which is also in the formula sheet. I just haven't copied it here. So if we do that, we get sin x cos h plus sin h cos x. And then, of course, we've still got the take away sin x here. Right, for the next step, for the third line, that's where you need to apply the small angle approximations. So this little cos h here is going to be replaced with 1 minus half h squared, and this little sin h here is going to be replaced by h. As you can see, everything else stays the same. Now, the next line, we just need to expand this bracket here. So we've got sin x multiplied by this bracket here. So let's just expand that. And by doing so, you spot now, just like in simpler polynomial differentiations from first principles, you should find that any term remaining that doesn't have an h in cancels. There we have it. The sin x and a minus sin x both cancel with each other, just leaving terms with an h in. And that allows us, and don't forget to write that out again, don't cancel the h's in this step, write it out again, just with what's remaining, and then cancel the h's, so that the examiner can see that you've done this systematically. Cancel the h's, finally rewrite out what's remaining, and of course now as h tends to 0, this term here will tend to 0, and we can therefore ignore it, and that just leaves cos x. And you should at this point just pause the video and try to do this whole process for y equals cos x instead. Here's a template. Okay, you should pause it here and try and do this yourself. Okay, assuming that you've already now done that, here is my solution. We first apply the formula, just without simplifying at all. Then we're going to use the compound angle formula to expand cos x plus h. That gives us line 2. Then we're going to apply the small angle approximations on this cos h here and this sin h here, which gives us line 3. Then we're going to expand this bracket here, and that allows us to, in the same step, cancel any terms that don't have an h in. And then we rewrite that out again, and this time we get a chance to cancel the h's, because there's now an h multiplied by every term, as a factor rather. Then we finally rewrite out what was left, and now let h tend to 0, which eliminates this term here, which goes to 0, just leaving minus sin x.